And talking about gray zone and continuing from the talk of Giovanni, I'm going to be talking about day 3 embryos, halfway there or more. So during this talk, I'm going to give an assessment of the morphological assessments we do on day 3, talk about how time-lapse has aided in day 3 assessments and the perspectives and value of performing assessment on day 3 embryos. So continuing with after fertilization, our aim in the embryology laboratory is to assess embryo quality based on the potential of embryos to be utilized in order to select the best embryo for transfer, or in order to select embryos to be vitrified, whether it's supernumerary or if we're having a freeze-all embryo cycle. And the selection of embryos based on morphology still remains the gold standard in embryology. However, this is a challenge for majority of embryologists in order to assess the embryos on day 3. And why is that? As embryologists, we should correlate the observed features of embryos with their implantation potential. And to help us, and for this purpose, to assess the embryos, several embryo classification systems have been developed based on different parameters. First parameter that we assess is the number of blastomeres. We know that an embryo on day 3 can have anywhere from 5 and sometimes 12, 13, even more cells. Also, the degree of fragmentation is a very important parameter that we assess. We have embryos that have 0 fragmentation, very nice embryos. Sometimes there might be some fragmentation between 20 to 25%. We can see in this image here. Sometimes it can be scattered. Sometimes it can be located in a specific section of the embryo. Here we can see another embryo with around 25%. But sometimes this fragmentation can exceed 25. Sometimes it can even span to 50% of the embryo. And the fragments are membrane-bound extracellular cytoplasm, and the evidence suggests that there is a heterogeneity in terms of their origin. It can sometimes be cellular origin, it can sometimes be molecular. It can be caused by undergenerated polar bodies. It can be cells with micronuclei. It can be caused by cell death. Sometimes it could be whole blastomeres. Sometimes it can be blebbings and vesicles. The symmetry of blastomeres is also an important parameter. And when we're talking about symmetry, first of all, we have to talk about whether the cells are equal size. And we can see on the left side here, equal size blastomeres between 5 and 8 cells. And on the right-hand side, we can see unequal size blastomeres. But that's not the only thing we look at when it comes to symmetry. Other than equal and unequal, we have to also look whether those relative cell sizes are cell stage specific in relation to the number of division cycles. And what do we mean by that? Here, for example, we have a nice 8-cell embryo. This is cell stage specific. The embryo has finished its 3rd round of division successfully. So 3 rounds of division has led to 8 cells. Here we can see another 8-cell embryo. However, one of the cells is almost double the size. This means that when this embryo divides, it's going to give rise to a 9-cell embryo. Therefore, this embryo has entered the 4th round of division and is not cell stage specific. And another example here, we see a 6-cell embryo with 2 large blastomeres, which when they divide, they're going to give rise to an 8-cell embryo. So this is a cell stage specific embryo. Also, the presence of multinucleation is another parameter that we assess. We can have embryos that are mononucleated, as we can see here. Easier to see on day 3 than compared to on day 2 compared to day 3. And here we can see a binucleated cell. That is not a good sign for development. Also, the compaction status is another parameter. Here we see a day 3 embryo that is not compacted. Here we see an embryo that has started its compaction process. And here we can see an embryo that it has a little bit of moderate compaction. So all of these parameters are important and have been shown to be correlated with pregnancies and live birth outcomes. So in terms of how do we assess these parameters and which are important, there are country-specific consensus schemes that have been developed over the years and updated over the years. For example, the Spanish society has developed its own consensus scheme. It grades the embryos, assigning grades from A to D, taking into account the progression from day 2 to day 3, the number of cells, levels of fragments, symmetry, multinucleation, and other features. Also in the UK, there is their own grading scheme, the ACE-NECA scheme. And this is based on assigning 3 numerical scores of the embryos. The first score is the number of cells, followed by a grade from 1 to 4 of the blastomer size that can be stage-specific or non-stage-specific accordingly, and then the level of fragmentation. So going from the number of cells to the score of the blastomer size to the score of the fragmentation. Also, USA has its own scheme and assigns scores from good, fair, and poor that are based on cell numbers, fragmentation levels, and symmetry. So the summarization of these points from all the different consensuses has been developed in the Istanbul Consensus. This is the first edition of the consensus. Before now, Giovanni has talked about the new edition that has finished its round of stakeholder reviews and is about to be officially published. So according to the first consensus, the timing of observation matters when it comes to day 3 embryos, and this assessment should be conducted at 68 hours post-insemination. Also, the expected stage of development at the time of observation matters. The embryo should be at the 8-cell stage at this time. So the consensus scoring scheme assigns a good, fair, and poor rating, again, taking into consideration fragmentation, stage-specific cell size, and the presence or not of multinucleation, with the optimal day 3 embryo defined, an embryo that is characterized at 68 hours post-insemination, that having 8 equally sized mononucleated blastomers in a 3-dimensional tetrahedral arrangement with less than 10% fragmentation. But when it comes to all of these observational parameters, which is the most important one? A number of studies show that the number of blastomers at a specific time is the most important parameter when it comes to embryo scoring. Also, from SART data from around 30,000 fresh day 3 embryo transfers, it has been shown that the highest live birth rates are derived when an 8-cell embryo is being transferred. And as we can see here in these graphs, we can see that the 8-cell embryos result in the highest live birth rate. And when this is accompanied by a low fragmentation level, then this level is even higher. So in the last decade or even more, time-lapse has entered our life. Has that knowledge aided in amending or improving what we understand about day 3 embryo assessments? Is the consensus still valid? We know that the traditional static snapshot assessment that is done once or twice daily is blind to information in regards to the development between those observation time points. And this can have limitations. We can miss abnormal cell divisions of the embryos. The embryo itself may have an improved or worsened prognosis within a couple of hours through creation or reabsorption of fragments. Also, the cultural conditions between laboratories vary. The timing varies between assessments. Coming from different laboratories, you know that not everything is done based on timing sometimes. Also, a cell and a large fragment can sometimes look similar and be confusing. There is also embryology subjectivity. We know that as embryologists, we have inter and intra-observer variability. There's a number of studies that show this. So different embryologists can grade embryos differently, or even the same embryologist can change their grading over time of the same embryo. But we know that time-lapse itself does not improve live birth rates, and there's a number of randomized controlled trials and meta-analyses that show this. but there is still value in utilizing time-lapse technology. It allows us, first of all, to assess timings and give us a detailed analysis of the developmental parameters over time. It also picks up the incidence of abnormal cleavages, such as direct cleavage, that can affect embryo viability. And this has led to the revised Istanbul consensus that is now going to be published. And according to the consensus, the ranking of day 3 embryo transfer varies from top ranking to intermediate ranking and low ranking. With when talking about day 3, the top ranking embryo should have an 8 cell. If more, is given an intermediate score. If less, is given a low ranked. The cell size, fragmentation, multinucleation, as we described before, remain important parameters, as well as compaction. Compaction should start above the 8 cell stage. And also, any embryos that have abnormal cleavages should be cultured to the blastocyst in order to evaluate their potential. And a number of studies that have led to these recommendations are being presented. You can visit that at your own leisure following the talks. However, what else offer? Is there an optimal development? And yes, the studies show that there is an optimal developmental speed when it comes to embryo development. We know that good quality embryos exhibit appropriate kinetics and synchrony of cell division. We know that too fast or too slow embryo cleavage rate has a negative impact on embryo development, and the slow or fast embryos may have metabolic and or chromosomal defects. So it is a matter of speed. And morphokinetics provides information for the normal distribution of embryo developmental timings. We can see here that a range at which the embryos are viable, a time frame of times post-insemination, that embryos are viable, that can create blastocysts and can be implanted having regular divisions. Also, there are studies showing that fast-growing embryos on day 3 that have more than 8 cells have a higher rate of aneuploidy. We can see here that over 9 cells, the aneuploidy rate increases compared to 7, 8, and 9 cells. There are also studies that show that fast-growing embryos on day 3 have an increased incidence of abnormal cleavage patterns. And we can see here with the green color, we can see normal behavior, so normal cleavage that is higher when we have a 7 or 8 cell embryo. And when we have delayed development, so when we have 5 or 6 cells, we have increased fragmentation with the blue color. And when we have advanced and fast embryos, we have more direct cleavage divisions. We can see that in the red color. There are also studies that show that fast-growing embryos on day 3, more than 8 cells and up to 11 cells, are less likely to make blastocysts. But if they make it to the blastocyst, they thereafter have good potential. So we can see here with the 8 cells, the blastulation rate is very high. It drops a little bit after when it comes to 9, 10, 11, 12 cells. And after 13, it picks up again. And that is also correlated with the blastocyst, with the euploid blastocyst rate. So euploid blastocyst rate, when it comes to fast embryos, it's only up to 11 cells. And then it seems that more faster embryos can somewhat be okay. When it comes to slow developing embryos, those have also limitations and have lower developmental competence to the blastocyst stage. And we can see here with the black bars that the delayed embryos are the ones that are not developed to the blastocyst stage, and the timing it takes to complete the divisions and the creation of cells from 2 to 5 shows that those embryos are less likely to make it to the blastocyst stage. And also slow developing embryos have worse prediction for implantation. We can see with the blue line, those embryos that have led to implantation, and with the red line, those embryos that are delayed and don't lead to implantation. time can also help us dissociate between good quality embryos and top quality embryos. So there are studies there that show that AA blastocysts from BB blastocysts can be distinguished using morphokinetics. So when it comes to time, we have to take into consideration that the environment in the laboratory itself can influence the kinetics of development. And there is a number of different parameters that can affect within the IVF laboratory, within our culture systems, with the patients themselves, the gamete quality, the embryo sex, they can all affect kinetics. So this we have to have in mind in our own setting. But what is the importance of assessing an embryo on day 3? Why do we need to do it? It can help us identify the best embryo for cleavage stage embryo transfer. Can we identify that embryo? So we know that the laboratory conditions are yet to fully mimic the physiological conditions that embryos face within the female tract. However, majority of labs, we do extended embryo culture to day 5, and this is considered the gold standard because it is compatible with an embryo biopsy at the blastocyst stage, and it is the optimal marker for embryo selection, enabling a single embryo transfer. However, there are some large register-based studies that associate day 5 culture and extended cultures with a higher rate of placenta previa and preterm birth compared to cleavage stage transfers. And when it comes to comparing cleavage stage to blastocyst transfer, there is not enough evidence to suggest whereas cleavage stage is superior to blastocyst. But is that because we don't have enough data yet using artificial intelligence and time-lapse technologies? We know that now artificial intelligence can predict blastocyst development from the cleavage stage. A number of studies that show this. There is also studies now that correlate morphology and that correlate morphokinetics on day 3 with euploidy and aneuploidy. So therefore, will there be a change going forward? Also, assessing embryos on day 3 can potentially help us identify embryos that are not meant to develop and make it to the blastocyst stage. We know that many embryos from a single cohort from a patient are not destined to develop and make it to the blastocyst stage. Therefore, morphokinetics could help us, or algorithms could help us to negatively select embryos based on their incapacity to make it to the blastocyst stage. It can help labs to avoid unnecessary extended cultures. It can be used as counseling tools for patients. So overall, day 3 embryo assessment by a single static observation might not accurately be used to rank embryos. There is an optimal development speed based on day 3 embryo morphokinetics. However, we do require further studies that can potentially enable us to identify developmentally incompetent embryos, chromosomally competent embryos, as well as the best embryo for cleavage stage transfer, and that can lead to streamlined laboratory practices. Thank you very much for listening.